You've seen the memes. You've heard the fun fact in gaming lobbies. Did you know the Russians put ice on their tanks? It's like free armor. It sounds crazy, right? A block of frozen water stopping a high-velocity, armor-piercing tank shell. Today, we're not just asking the question, we're going to war with physics to find out. Can ice really stop a tank shell? So where did this idea even come from? Most point to World War II and the Soviet Union. During the brutal winter on the Eastern Front, temperatures dropped to 40 degrees Celsius. Tanks, like the famous T-34, would often get caked in a thick layer of frozen mud and ice. Now, imagine a tired German soldier taking a shot with his Panzerfaust. It hits the tank, there's a flash, but the tank keeps rolling. The soldier thinks, my grenade just hit solid ice and it did nothing. The story spreads. Ice as armor was born. But was it the ice? Or was there something else going on? To understand if ice can work, we need to understand what we're asking it to do. We're not asking it to be hard. We're asking it to dissipate a massive amount of kinetic energy. Let's break down the two main types of tank shells we're talking about. 1. Kinetic energy penetrators, APFSDS, the DART. This is a long, dense rod of tungsten or depleted uranium, fired at insane speeds, over 1,500 meters per second. It doesn't explode. It just punches through sheer force. To stop this, a material needs to be incredibly hard and tough to shatter the dart or deflect it. 2. High explosive anti-tank, HEAT, the shaped charge. This shell explodes on impact, focusing a jet of superheated metal and plasma into a tiny point to melt through armor. To stop this, you need to disrupt that perfect focused jet. So, how does ice stack up? Ice versus steel. The material showdown. Let's look at the numbers. Hardness, Brunel scale. O rolled homogeneous armor. Steel the 300-500 BHN, O pure ice. At 10 to guide, no 1-2 BHN. O steel is literally hundreds of times harder. Tensile strength O steel, around 400-500 megapascals, MPa. O ice, a measly 1-2 MPa. Ice is brittle. When stressed, it doesn't bend. It cracks and shatters. A tank shell is the definition of stress. So, the direct answer is no. A standalone block of ice, no matter how thick, cannot stop a modern tank shell head-on. The shell would pass through it like a hot knife through butter, barely even noticing it was there. But wait, the myth is so persistent because there's a tiny specific scenario where ice might have an effect, and it's all about the heat shell. Remember that shaped charge jet? It's perfectly timed and focused. If you have a layer of ice standing off from the main armor, say 6 to 12 inches away, it can do two things. 1. Premature detonation. It causes the heat shell to explode too early. The jet still forms, but it has to travel through empty air before it even reaches the actual armor. This gives the jet time to spread out and lose its focus, reducing its penetrating power. 2. Disruption. The jet hitting the ice creates turbulence. It's not that the ice stops the jet, but it makes it less efficient. In this very specific case, the ice isn't acting as armor. It's acting as spaced armor, or a disruptor. It's the gap that's doing the work, not the ice itself. A wooden plank or a sheet of thin metal at the same distance would likely work just as well, if not better. So in Dobiavti, that layer of frozen mud and ice might have provided just enough standoff to degrade a poor quality early Panzerfaust hit. It wasn't the ice's strength, it was its position. So, let's deliver the final verdict. A slab of ice cannot and will not stop a kinetic penetrator or a heat round on its own merits. Its material properties are laughably inadequate for the task. However, the myth gets one thing half right. In the specific context of disrupting a shaped charge warhead, a standoff layer of ice could potentially reduce the shell's effectiveness. But it's an incredibly unreliable and inefficient form of protection. The next time you hear someone say, ice is as good as tank armor, you can tell them the cold, hard truth. Thanks for watching. Was there a layer of truth to this myth, or was it all just a snow job? Let me know in the comments. what other myths you want me to break down next. Don't forget to like and subscribe for more debunks.